Hi, I'm Anthony Pagan. In this data science and context presentation, I will be discussing simulations. I'll begin with why simulations are used, then give some differences between simulations and pattern recognition, and briefly discuss some of the known use cases. I will then show some code examples in R and Python. So simulations are used in data science to programmatically repeat an action so we can uncover new meaning from the existing data. In simulations, we are trying to avoid repeating code and instead reuse code in loops. Simulations are used in experiment to test hypotheses and to forecast future trends. Without simulations, the manual process of surveys and code repetition would be costly and time-consuming. The difference between pattern recognition and simulations are that pattern recognition tries to find future trends by finding patterns in the dataset. So this is a form of unsupervised learning, as it needs minimum upfront knowledge of the data and tries to uncover unknown causal relationships in the dataset. In comparison, simulations are a form of supervised learning, as it uses the existing data to build models to help estimate missing factors. Simulations try to find future trends by analyzing cause and effect. It can use less data as it will forecast on the data set it knows. This can reduce processing time. Some known use cases include market basket analysis, where businesses try to tell which items a consumer will buy based on recent purchases. Another example is self-driving cars, where driverless cars are trained extensively on virtual simulations to prepare the vehicle for nearly every event on the road. Then there's the employee shift analysis, where employers try to predict how much staff will be required to service consumers. In addition, simulations can be used for bias-related analysis like jury selection. There are countless of many more examples. In this example, we are using R. In R, we would normally use set.c to make the code reproducible and do a sample of the normal distribution functions. But in this example, we're just using a simmer function. This specific code executes a discrete event simulation which shows system changes in the precise point in a simulated time. In comparison, a continuous simulated event simulation would be based on continuous time. This specific data set has a list of medical staff composed of doctors, nurses, and administrators. The objective is to simulate several number of different staff members to determine which number of staff would reduce the patient queue time, which is basically the time a patient has to wait to be seen by a doctor. In the code, we're using the simmer function and run the function in several settings. In a normal environment, we would use a for loop to try to find the best settings. In this example, we run 3 different sets manually, and it shows that 4 doctors, 3 nurses, and 2 administrators would bring the patient queue down to 0. In this next example, we're using Python. In Python, we can use NumPy and sample proportion functions. The data set is based on a jury selection, and the code tries to determine if the selection was biased. It begins with a hypothesis that although the population in the district is composed of 26% of a specific ethnicity, the selection of 8% of that ethnicity to the jury was a random choice and not based on bias. The simulation uses the fact that the population is 26% of one ethnicity and 74% of others. It then simulates the random choice 10,000 times and puts the results in a normal distribution curve. The normal curve shows that on average, the selection would equate to 20 to 30% of the population, and 95% of that simulation ranges from 13 to 37% of the population. So as a result, the 8% selection was out of range and therefore it is very unlikely that the jury selection was a random choice and instead was biased. In conclusion, without simulations, prediction and forecasting will be time-consuming and costly. Thank you.